Hi everyone, welcome to the TAC 2020 Day 2 Product Stability session. Hope you're all doing safe, and I would like to briefly introduce Mr. Ranjith Tharayil today. Ranjith Tharayil leads the Agile Engineering Practices and Agile Dojo capability for Accenture across India, and is also honored with the title Distinguished Speaker by Association for Computing Machinery. He's a business coach who strongly believes in influencing skills of leaders and is known as mentor of change. Ranjith is a very humble personality, as I've met him personally, and he has 9 patents to his credit. He's also authored several publications and penned articles across different domains. And also, I would like to welcome the participants here. Please post your questions, and it will be taken up at the end of the session. And don't forget to post the poll votings at the end of the session. And without further delay, I would like to welcome Ranjith. Thanks for joining the session today, and thank you, audience. Over to you, Ranjith.
Yeah, good morning, good afternoon, and good evening, friends. Thank you for joining in this session. What we would be discussing in this next 45 minutes is a bit of my experience on how we could test drive self-learning systems towards continuous delivery. Now, I know there's a lot of fancy names put over there just to beef up the title, but what we are actually looking at is we've seen that in fact, a lot of you who would be right now would be working on ML-based AI systems, machine learning systems. And in this particular context, what are the difficulties or impediments when it comes towards test driving? So when we say test driving is first itself is thinking about test first and then driving the design of the system. And also to check out what are the nuances when we end up writing unit test or acceptance test or end-to-end test on these systems. What are these problems and how we could mitigate this? Saying so, this is just from my experience, and my knowledge base is very small compared to the knowledge or depth that you guys are having. So in case if things make sense, please append it to your larger knowledge base. And if things are not making sense, just pardon me. Okay. So let's get started. This is a disclaimer that I need to intentionally show from my company. Okay. So this was around a few years ago, and when I was working along with a financial giant, one of the largest insurance players in Europe, and they were in reinsurance business. And primary business was reinsurance business. And when you say reinsurance, it's about insuring or buying insurance of already existing insurance. So whenever a company feels that they are overexposed over a particular kind of insurance, in order to reduce the risk, they sell it, and other larger firms can actually buy it. So what happened was that in one of their quarters, their reinsurance business targets were not met and drastically fell down. And this was one of the area of concern, and they brought in a set of experts, auditors, and they identified that the key root problem was a technological glitch that had entered into their software systems. And now this being a pretty mature firm, and they had adopted XP practices a pretty long time, and they were confident that and they were a bit surprised at how could such a defect get into their system. And that's when I was pulled in, and I was the technical coach acting for that particular company. And they called me up in this particular room where we had the CTO in a video call talking about what impact this particular defect has brought in and how could we ensure that it doesn't happen. Even I was a bit stunned to see that because we're this company or this program was boasting about having 90% of coverage across the various systems that they were building. And how could such a defect creep in was an area of interest. And we started investigating. We started doing a discovery, trying to understand this team's way of working. And it was in the first or second day itself, we caught the problem. And though they had a lot of tests being written, a lot of these asserts were commented out. And it was a genuine ask. I mean, it was not so natural for any developer with some amount of intelligence to comment asserts, right, in a test, because that's where the heart of a test lies. And when we asked him, so there were a bunch of developers, and they were genuinely saying that, Ranjith, what we were facing is that though we have written these tests and it was constantly breaking. So that was something that was put forward. I said, no, let's try it out. Let's get this fixed. Let's clean it up. Let's ensure that the tests don't break. And we first did that cut. We ensured that the tests were all green. We put it onto production. And again, when we had after a couple of weeks, we saw that the tests were again breaking down. So that's when we started getting a little bit more deeper and trying to understand the system. So by the way, this particular system, whichever we are talking about of reinsurance, had a small bit of calculation, which is called the risk calculator, which typically identifies what is the risk associated with a particular customer in case of the reassurance business. And based on that risk parameters is when their entire business revolves, whether to go for the deal or not do the deal, whether should we have a bigger premium asked. All these things are based on that particular risk number. For some reason, this risk number is what was not showing up right. And this risk number was a calculator. Risk calculator was totally based on an ML-based system, which they had built over the last few years. And this ML-based system was not just learning, but it was learning continuously based on the data that was coming in. They were learning continuously. So, by the way, just a small introduction here. I'll not go to the depths of ML because I'm assuming that people who have joined here are already working in such spaces or have some knowledge. So the scope of this particular talk is not to explain what ML is. So I assume that is already there, and we'll take it forward from that particular point. So one of the key things we need to understand is how a traditional system work, a non-AI or ML-based system work is. You have a function, assume that is the function that you have written a code. That's what you are seeing. Let me just take the laser point. That's what exactly you're seeing over here. This is a non-AI system, okay? So once you have an input A, your output is going to be BB because your output is always a function of the input and the code you write. Now, assume that this particular system, which we are talking about, the risk calculator, was written in a conventional way, that is a non-AI way or an ML or non-ML based system. What we would have done is we would have a bunch of if and else conditions or case conditions, and that's what would have baked into this function. And if you give a particular input, the output is always going to be constant. So that's what we were trying to say. So the output of a system, of a traditional system, is always a function of the input and the code. If either of these changes, the output changes. And this is the sole basis of how we write tests, right? Now just assume that how we would write a test for a particular functionality like this. We would say that this particular function should return B when input is A. So whenever there is input AA given, the output should always be BB, and that's what we assert with. We say that if it's not BB, then some problem is there, okay, where the input is A. You're passing AA to the function, and this function should return BB as the input. This is the standard way of testing a standard non-ML based system. Now the question is that, will such test work for ML based system? Now let's try to understand how an ML based system works, okay, in a similar analogy. So you have an input that goes in. Definitely there are various inputs that goes in. You have a function or code that binds it, but you also have something that is in the yellow, which is a statistical model. So earlier you had all the ifs and buts, ifs and else over here. That entire logic now gets baked into these statistical models because a lot of this functionality is now right over here. You will have some functionality on top of the overarching functionalities, but still there's a lot that gets baked into these statistical models. Now what this means is that your output now is not just a function of input and code, but also the model. Now there is this third variable that is coming in, and this is what would create the problem. And now when you're talking about self-learning systems, is that this model is not static. It's going to continuously change. When I say is that so you've seen this continuously changing models, right? To get more better results, what happens is that the data, whatever is being entered or wherever it is being acquired, it keeps on updating, and the models are updated very frequently on a continuous delivery basis. So this means that this model, what we are talking itself is not constant. It changes at every time. So the output now is in a function of 3 in which the model is continuous. Because of that, such kind of test won't work. Because what happens is that today maybe your input is AA and you will get BB, but tomorrow, because your model changed, and that's an automatic change that happens, your output could be BC. Day after tomorrow, it could be BD. It could go on. You could never be deterministic on what would be the specific output. Because of that, such kind of, we call this test a state test. We are trying to check the state of various system variables, right? So that's what we call it as state test. I think you can Google it, you can find a hell lot of documentation on what state tests are. So such kind of test doesn't work in an ML-based system. And that's what was the key problem that we were facing. I think it's extremely crucial in this space to understand the problem. And what we were facing is that, especially when you're talking about test-driven development, if we have such systems, and it will definitely, the developers are not going to build right with state system because they know that it's going to break, and what's the point in doing it? So test-driving development was difficult for self-learning system. That's one of the problem statement. Output of the system was depending on the model. And that was a key problem why tests were flaky. You could write a test, it would pass, but in future it could fail. Model changes very frequently, and that's the reason why the test becomes flaky. And in case of continuous delivery, one thing that you need to be ultra confident is that your test automation is really great. Otherwise, you'll never be able to do continuous delivery, right? So this actually shakes down the confidence. Though there is no specific problems in the system, but still the system identifies this as a false positive. So you'd start disbelieving your test, and that's a very bad situation, especially if you are in a CI/CD mode to get into. So now the question was, we understood the problem statement, and how should we focus, or what should be our strategy be? And that's what I'm saying. This is one of the strategies, and it need not be the ultimate strategy. So if you have something that you have built, and if you see something is interesting, feel free to take and let's discuss on how it could be made. But this is just one of it. Okay. Step one, what you're seeing on the right is various steps that I'm using. Feel free to take screenshots wherever necessary, if ever you like. So what you're seeing over here is step one. So I've marked it as a 4-step process. The first step is to identify or demarcate or refactor your existing code bases into 3 parameters or 3 subsystems. So prior to that, you need to first identify 2 kinds of subsystem: your general business logic and your AI system, or ML-based AI system, AI-based ML system. First thing is to identify that boundary, and within what you're seeing is in this particular dotted lines, right? This is your AI system. Underneath this, you are segregating them into 3 different subsystems. Now I'll just explain these subsystems. One is in the yellow one, which is typically a business logic that you are writing, and it's right on top of your AI or ML based systems. Okay. So it should be a very surface level, which is more of software that's interacting to your AI system. It should be very thin because other business logic should be covered here. Then this general business logic, you can use your traditional way of writing ATDD test or behavior-driven test at the upper layer, and inner layer you could use a test-driven development approach. So this uses a standard flow. Now we're talking about this particular thing, and here it's just the layer that interacts with your AI system. Now you would have another set of software which you might have written or you might have acquired from third-party libraries. This is the standard algorithms that perform various interactions. If you're using Python, you would find a whole lot of libraries available, right? It's also you should also make sure, though you're using it, you're getting the right results. So as if you're running commercial software, you can't just say that that's not written by me and I don't want to vouch for its quality. But if you are writing it, putting a system together, you also want to make sure that it's also getting tested. And also along with that, we have data structures, right? This is something that especially we are dealing with data models. Once you want to do some computation on top of it, these data, you need data structures. For example, you might need graphs, you might need hash maps, and things like that. That is specifically that's going to read the model and do some kind of optimization so that you can access the model pretty fast. So that's the second layer. And if you are into ML machine learning, I think this could be something that you can easily relate with. And the third one is the model itself, which is actually the hardcore model where the learning all has happened and all the logic is being baked in. And this is more static and you don't have any code over here. Okay, all the code has been separated. Now the question that you might have is that why should I refactor it into these three parts? The reason of refactoring is that you need to handle these three subsystems of your AI with respect to testing in a different way, so that you can test drive these in using three different strategies. And that's the reason why you have to have clear demarcation. Now, for this, I typically do a hands-on on this. So because of time limitation, we can't do. So what I'm trying to do is that I'm trying to bring in an example so that you understand this a little bit more, because without an example, this is going to be a little bit difficult for you to understand. Now, the example that I'm taking is a very simple example, but that doesn't mean that the same thing can be applied to complex projects within your products that you're developing. You can extrapolate it and definitely use it. So the example that we are using is something that we have all used. You all have mobiles, right? And you have keyboards that come whenever you want to chat or you want to email. In this particular keyboard, whenever you type, you've seen some kind of prediction happening. For example, here when I'm typing, where should we celebrate your promote? I've not written promotion clearly, but I've just written PROMOT. It gives me that promotion could be the most probable word that you want to use. Now assume that you want to build this prediction logic. Okay, you're building a customized prediction logic. Okay, this is just a hypothetical example so that I can explain you. Now, a couple of domain terms that I might want to use. I'm trying to keep it as simple as it, because without which I'll not be able to explain this. Typically, in order to achieve this, we would need some kind of some kind of predictive models. So one is called a unigram model. Unigram model you can consider it as simple as it. Assume that you have data of your past 1 month of chatting, okay, 1 month or 1 year. And you go word by word, and the topmost frequently used word gets the highest priority. And you create a table like that. All the words that you have used in your keyboard, there's a system that counts how frequently have you used it, and based on that, it creates a table where the topmost one has got the highest probability. For example, over here you can see promotion is having a very high probability compared to that of promoting. So that's just a simple. So the right hand side, this particular column is the probability. As simple as it. There's nothing complex in this. Similar to this, you have bigram tables. Now, bigram table is where when you are looking it in combination. For example, when I say good, the chances that I say good morning is much more higher than something like good sleep, right? Maybe good morning comes up higher. So this is the combination of whenever you're looking at two words, what is the probability of that particular two word happening? So this is a bigram, and if you look at the real world prediction systems, they use n-grams. It goes on. So let's limit ourselves because our sake is not to explain this right now. Now you've understood these two. Now I'm going to talk about the business logic. Now don't question me about the business logic. I'm just creating a hypothetical business logic so that we have a problem to solve. Okay. The business logic is that in case I am going to type a word partially, for example, I'm typing PROMOT. I'm not typing a space after that. I'm not typing a space. In that particular case, I would want my system to look into this table and identify the most probable word. Okay. So this is rule 1. So whenever I'm typing in between of a word, that is, I'm partially typing a word and not complete, then I want to make it use the unigram model for prediction. Whereas if ever I'm typing a full word and then I'm hitting a space bar, that is, I'm hitting a space bar, then I should look for the bigram table to fill in. For example, over here, when I type where, my bigram table as of now is showing where should is having more probability than where is. So should be the right word that it should give. So the logic is clear, right? I have something as a bigram table and a unigram table, and whenever I'm partial word is being typed, it should take it from the unigram table. Whenever there is a full word typed and a space typed, after if there is a space type, immediately I should look for the bigram table to find the right prediction. Okay, simple. Now, how would my system, we talked about separating it into three levels of, say, three levels of refactoring, right? How would my system, the first thing is the business logic binding the AI system. Now, assume that this is the world-class prediction system, and whatever I just told you, switching from unigram, bigram is a patented technology, and this is something unique that I'm bringing out, though it's not, just hypothetically. Now, what would be my business logic is that the predict would need to switch between unigram and bigram based on whether there is a space. So the code is eventually going to look like there's going to be an if condition, and there's going to be saying that if in my sentence, if there is a trailing space, then go for bigram. If there is no space, go to unigram. So this is my core business logic that I've separated out. Now, there could be some algorithms required, right? Because if you're looking at the table, number of words in the dictionary that you might have is pretty huge. And you might need to have some kind of optimization hashing mechanism or tree-based mechanism to hold this data. You can't just go to your flat file and check, because it's not going to be fast, because you want predictions to be ultra fast. So you also would have some caching mechanism where you would want certain frequently your used words to immediately come back rather than looking and checking and finding it on. So all this algorithms and your data structures, you are separating it out in this particular case. And over here, the model is these two tables. So assume that these are two in your database or in a flat file. For simplicity, we'll assume that these are in a flat file, and you have separated this out as three levels of subsystem. Now, what you're seeing in step 2 over here is that we are trying to define how should we test this particular segment. That is the business logic, okay? The business logic is typically, I have a predict function. This is the yellow part is what we are testing. I have a predict function, and this predict function use unigram and bigram model, which is part of the standard AI libraries that is available. Based on my world-class prediction mechanism, where if there is a space that is trailing, I should use bigram, else I should use unigram. That's my business logic that I need to, which is binding that I need to test. Now, if I try something like this as a state test, like we saw that, right? Should, where should was more probable. So whenever I'm going where, and if I'm typing SH, it should ideally go to my unigram table, and maybe if should is the topmost probable item, then it should bring me should. But the problem is this test is not going to work always. If and only should was on top of the table, it would have given me. Now assume that I've been typing a lot, I've been watching a lot of Big Bang Theory, and I'm typing Sheldon many times and talking about how Sheldon behaved and this and that. Maybe should mind in the due time should might go to second place, and Sheldon might come as in the first place. So maybe what this guy returns is where Sheldon, which is perfectly fine from a system point, but this test would not pass because it's not should. So this would not work. So how would we attempt writing test in this case is what? We need to rely on something called as interaction testing. Now look at the word, it's not integration testing, it's interaction testing. Interaction testing is also another kind of unit test, which I feel in the industry, a lot of people don't use. Only experts, I've seen them using this. Now, interaction test is a test which doesn't test the state of predict, but rather than checks whether, am I calling the right function? It's checking these arrows. It's checking whether, am I interacting the right way? Am I calling the right thing? For example, I'll just show you an interaction test where we could replace this test as. For this, you might need to use some mocking algorithms, like mocking frameworks. Like in this case, I've used JMock. You could have Mockito, or in Python, you have their own mocking frameworks. Across the spectrum of tools, you have mocking frameworks. So don't worry about that. Whatever code base you're using, there would be a mocking framework available. Also, if you don't have it, you can just create it overnight. It's not so complex, the basic mocking framework. Okay. So what we have done is that this entire algorithm class we have mocked. So I'm not going to mocking over here because it would not give justice to this 45 minutes. So just assume that this entire class, there is a tool which I can I can mock it. So just assume that this functionality helps me to do that without creating the actual algorithm. So this entire blue part is mocked. And what I'm trying to do over here is that I'm passing in my predict function, I'm passing the string where should. So ideally, what I'm checking is that is unigram function getting called with these parameters. I'm checking whether this connection is getting called or triggered and whether it is getting called one time. So let's not get into the syntax of it because we don't have time. But what eventually we are doing is that we are testing the behavior. We are not testing the state. Similarly, I could write the test for should look up from bigram, and based on that, if ever I had a space, I would have that whether bigram is getting called. So such interaction test is required to cover this particular space, because whenever you write a state test, it's going to be flaky. So this is one thing that you need to keep in mind. So this kind of interaction test is not dependent on the model because it's just checking whether you are interacting right. Eventually also, if you look at it, right, it's not predict's responsibility to show whether it is should or some other word, Sheldon. It's up to the model to define. So it's not a responsibility. The predict's responsibility is only to, if it's case it's having a trailing space, go to bigram, else go to unigram. So that's what predict's responsibility is. So eventually you're checking that. You're checking the behavior rightly. Now, just summarizing, this is the point where you want to take a screenshot, you can take it, where you are focusing on interactions and behaviors over state. You're avoiding state testing. You're using a mocking framework to achieve this. And typically you write it as a unit test. Why? Because once you are mocking it, what happens is that you're going to go much faster because you're not actually using the libraries. Your tests are much faster. And it's more of a white box test. You need to know what is it. So typically you add these kinds of tests at the unit level. And this will be pretty fast from a speed point of view because you're mocking this entire thing. So I'll just take 2 seconds for you to just digest this so that we're going to the third step where we are trying to see how we would probably test the second layer. So now we are over here. The second layer is basically the algorithms and data structures that we would be using. So in production, this is something that we had already shown, right? In production, it's going to be like the output is dependent on input, model, and the code. Code and the model. Okay, and there are 3 variables coming here, and this is what is going to happen in production. But if you are in a test environment, one small tweak that you can do is that you can take a model and make it constant, because rather than going for a changing model only in the test environment, what you say is that you bring in a simple model. In this particular case, what you're saying is that I'm going to use a standard table. I'm not going to edit or modify the table. I'm going to use a standard table for my bigrams and unigrams, which might have very fewer entries also, not all the words. And I'm going to write tests based on that. So now what happened is that you have made the model constant. That means your model is not going to change. And this can be only done if you can inject the model at a real-time basis, right? When I say using feature injection or any kind of method like that, you are able to inject it dynamically and you can give a mock model over here. Okay, so you're trying to mock the model itself by giving also a simpler model, which is more comprehensible, where you can write tests. Now, this should only be done during testing phase. It should not be done while in production, because this model is not going to work for you in real production. So only in the test context, you have to choose this model, and then what happens is the equation turns out that the output is a function of input and code. Now you can use your standard state test also. So this opens you a window, though it will not, for example, if you have an assumption that should is going to be always on top of the table, the previous test would work for you. So what you do is that you inject a fake model. I think you should be really sure that it's only in the test context, and in the production context, you should ensure that it is injecting the real model. The fake model, it should be same always. You can't go and changing this, because once you change this, your test is going to change. So you create something very simple, something that you can comprehend and you can write tests on. It should be simple to predict also, because you can't have very complex model over here, though there have been cases. We'll have to try to discuss this at a later point on why we need complex models as constant also. That's something out of this scope of discussion. And here you can use state testing rather than interaction testing, or you can use both. That's perfectly fine. And also the simple model, another advantage that we observed was that instead of using complex models, using a simple model over here, it becomes faster. When I'm saying simpler model, right, it doesn't mean that you have a graph, but the number of nodes might be less. Okay, you're making it smaller. So this means that you can run the test much faster in comparison. So that's another advantage when you go into CD, right? You want your test to run faster. So in our particular case, how we would have achieved is that we would have taken a fake bigram and a fake unigram, smaller a number of entries. All the other entries, we would have said that the probability is very low and we would have removed it out. So your tables are smaller. And you can add this. We typically can add it as an integration test, or a little bit of unit and an integration test. So that's where you typically place such kinds of tests. Another thing is that once you are having this, even for certain elements that you had not tested on your business unit layer, in case you want, you can test it also. That's another thing that we have seen. But typically, you keep this layer very thin, so you would not want to need that to do that. Now, the fourth step, and this is something which is very important. This is to actually test the model itself. Now, you might have a question, why should we test the model? Isn't it already being tested? Because if you know this traditional AI cycle, there is a test phase in which you use some amount of data to check whether the trained data is correct or not, and you again bake that trained data. Very well, that's well. But assume that you are building a continuous learning system, right? And assume that you have a car, or you're building a logic for an automated car that needs to drive. And whenever there is a red light that is shown, you need to stop the car. Okay, so this is a very standard requirement. And now red is pretty easy to understand, but what happens is that between red and green, when green you need to move, there are different shades, right? And there could be a special use case when there is mist, the green color looks a little bit more orangish, or the red color looks orange. So there are gray areas over here. And you would want to ensure that, especially when you are in such systems, there is some kind of acceptable variance that is defined. And you can't have self-learning systems to learn by themselves and go out of control, which we have already seen in many cases where totally they go out of control. You should give them a guardrail saying that this is the guardrail you need to stay in. This also comes in handy when you want to build responsible AI systems, where, for example, there are a lot of cases where black and brown colored people were denied certain benefits because AI systems were kind of trained in that way. It was unintentional, but it ended up in that way. So you would want to probably set that ground rules, right? Not this is what can acceptable, this is not acceptable. And that ground or that variance is something is very context specific, depends on the context. If it's something that is pretty accurate, then your variance is small. If you have a little bit more freedom, the variance is correct. It's very context dependent. So typically, you want, and especially in a continuous delivery system where these systems are getting deployed, or a continuous deployed systems, you would want to ensure this as a final check, so that as a smoke test, so that you're not deploying a system that could go haywire. So that's very important. So apart from the standard test that you do for the model, this is one last level gate to ensure that your model is also performing well. So for that, what we did was that we typically take a bunch of SMEs, and in this particular case, we would take standard sentence and ask the SME, what would you typically type based on, for example, certain words or certain things. And this could be different in different contexts. If it's an image processing algorithm, and if you're looking for a particular kind of a pattern, then that is done in that way. But in our case, typically you would write, okay, good morning. Okay, good morning is more probable at good, right? So anything related to morning could have a very high probability. And you ask a certain set of SMEs, and you create a truth set out of it. And this is something that you would always check from your prediction system. If it is having, it will not be accurate, but overall output, is it having kind of related to the truth set? Because this particular truth set is something that you would not used for training rather than it's used only for testing. And this is put on your continuous delivery pipeline. You would have dice coefficients in complex places where you might build this, and you would say that, yeah, it's good to go, or no, it's not good to go. We might need to see. It's at least we need to inspect and check whether it's something is wrong. The variance is totally going. So this is the way that you test the model also. So we had separated them into three parts, right? The AI system into three parts, and this is where how you test the model. Now, there's a lot of research in this specific area of what would be the what is the actual variance acceptable, how should the dice coefficient be computed, and this thing. That's not the area or focus of this particular talk. That's a separate talk where data scientists would need to spend in. But the key problem statement that I'm trying to address is that we need a final check, and this check is achieved using this, and this variance is what, this loop is what we would add in your continuous delivery pipeline. Okay. Now, just summarizing this, we would want to have a system like this. You don't use this data for training, very crucial, because once this data is used for training, your system is already biased to this data. So this data has to stand alone. And the variance is typically a threshold. It's not absolute, because the output that you get from this and this is not going to be accurately same. So you would define a variance, what is acceptable. In case of the light that we showed, the red light, right? What shade of red is acceptable as red, and what is not at all acceptable is something that is defined by an human expert over here. Okay, and then you add this. You typically add this as an end-to-end test it typically comes at a service and end-to-end test. So you typically add such kinds of tests at the higher of the pyramid. By the way, I'm showing this as a test pyramid. I hope you guys are aware of it, because I am expecting that it is known. And this is where we would typically place this kinds of tests. So these are the 4-level strategies what you look like. First is, this is a summary of what we are discussing. First thing is to understand the problem. It's very crucial. AI systems is very difficult to test drive. Test-driven development or test-first development is extremely difficult. Even unit testing itself is difficult. So we understand why it's difficult, because output of the system is not just dependent on the code and the input, but it's also dependent on the model. And then the model changes frequently. We are looking at a continuously self-learning, right? So this model is also changing based on various inputs that it's receiving, because these days self-learning models are becoming more popular because it gives more depth or accuracy to what we are doing. So in this particular context, it makes it even more difficult to write state tests. So in that particular case, what we did is that we divided the system, or we re-architected or refactored the system into 3 specific spaces. And in each space, we applied a particular kind of a strategy. The business logic had more of interaction test, note, state test. The standard AI libraries and data structures, we mocked the model itself. That is, this model is mocked. We used a static model and we applied state testing on top of it. And this model, what we do is we use a dice score. And also, I've seen that in this particular project, right? They also used A by B kind of a test where they actually deployed it and they were trying to get feedback on the 2 kinds of models that they had. So, and then they would finally tweak, but this is a very small subset, and it can't be used where it's a very highly critical system, because you have especially you can't use it in a system like automated car driving A by B, because you can't see a person failing and then coming back. But whereas in lesser critical system where failure is acceptable, you can try out this kind of approach of A by B also. Okay, and typically these kinds of tests end up as unit tests, though this is not 100%. Most of it will be heavy over here. The interaction test, the standard AI library, this goes over here as an acceptance, mostly center-ish of the pyramid, whereas the testing the model by using SMEs and using the dice score is typically an end-to-end test where you actually test the model. So it typically lies at this top half of the pyramid. I'll just pause and probably take some Q&A. I think we are 5 minutes exactly, right? Yep.
Thanks, Ranjan. I think we have one question. I'll just read it out for you. In
Sure.
case of constant model, we are testing only the code. In this case, for real coverage, we have to test the code against all the models, which is probably a requirement in AI systems. Is this understanding right?
Absolutely. So if you have multiple models, definitely you would want to create those mocks on those models and then ensure that those several models, I mean, if ever you have multiple models and that's your system architecture, right? It's definitely the understanding is right. You might want to test it for that. No doubt.
Thanks, Ranjith.
Yeah.
Any more questions? So we have a few more minutes, and I think probably Ranjit can take a few more questions if you have any.
Sure.
I think people are digesting so much of information technically.
Sure. I think I have to take time. I think I'm perfectly fine. I mean, this is a little bit too heavy also. But I hope people who are in AI field is something that you would have faced a similar problem. And the key thing over here is ensure that your teams test drive the system, even if it is an AI-based system. I've seen that a lot of people don't get inclined towards test-driven development and automated testing, and they always try to test last. And this is something that can be avoided totally. And this is the paradigm shift that we are trying to bring in. By applying this strategy, you could also test AI-based systems, even self-learning AI systems in a test-driven approach. Thank you.
Well, Ranjit, I think, those are the questions we had, and there are a lot of compliments coming in. Awesome presentation, many takeaways from this session, and thanks a lot for the time. Yep, we're at the top of the hour. Probably any more questions? Last question, guys. Anyone wants to ask? I would encourage all the audience to please put your opinion on the session at the poll.
Yeah, please do let me know your feedback. You can also reach me out at Ranjith Tharayil. You can just Google me. You'll find my LinkedIn page. And please feel free to ask any questions over there also. Also, I'll be here in the chat and you can directly ask me after the session. Thank you very much. It was a great honor to be part of this conference, and thank you for attending my session.
Ranjit, from the TAC team and as well as the audience, I would like to, thanks a lot for your time in spite of your busy schedule. And then it was an awesome technical conference session. And I'm sure people in the world of AI, right, it would have added a lot of values, and probably they'll reach out to you offline for more questions on this. And we look forward to more sessions from you going forward. And thanks a lot for your time. And I would like to thank all the audience on this session. And you can also go back to our next session, which will start in 10 minutes. I'll be stopping the streaming of the session right now. Thanks a lot, and everyone be safe. Bye-bye.
Bye-bye.